completely wrong every time we use it. We can't show our web cameras. We couldn't last time, and we thought that GoToWebinar had fixed it, but of course, no, that would be far too easy for them to get that working. And right now, two of the people that we're going to have on, they've been around, but we don't know where they've gone now as well. So it's all going well so far. It's all to play for.
Well, and to be fair, I disappeared for a little bit too. Maybe it's one of those weird things. People just disappear randomly, and
we've entered the twilight zone. That's what it is. Yeah, I noticed that Alistair was on last time this happened, so I'm going to blame Alistair. I think
it's bound to be my fault.
Yeah. It's probably a New Zealand thing, because New Zealand's in the future, and that's probably the problem.
That's true. Yeah, it's Thursday morning here, so.
Well, see, that's just weird. That's very weird. Okay, well, we're gonna try and carry on and get it all working for you. I apologise if it's a little bit up in the air, but you know, we do say this is unscripted, and we're not kidding when we say that. Let me make sure my screens are correct. Right, good. Okay, so let me just see what we're showing you right now. Good, it's my screen. Excellent. Okay, well, good afternoon, good morning, etc., etc. I've already said that bit. Welcome to TCoffeeAndCode. Today, Wednesday, 18th of August, unless you're watching the playback, in which case you're probably time traveling just like Alistair, and you're sometime in the future when it's all bright and shiny. This week, we're going to be talking about code profiling, optimization, performance tweaks, I suppose, and memory leaks as well, and what they do and what they don't do, and how they affect your code and ways to mitigate those. So basically all about runtime behavior and the things you can do to make your runtime behavior go a little bit better. Just a standard warranty disclaimer. I'm not going to read it all, but I'll just summarize it for you. The views, thoughts, and opinions expressed belong solely to the individual panelists and not necessarily to the other panelists, their employers, organizations, committees, and/or other groups and individuals. You can read the rest, but what we're really saying is that this is an informal chat. It's not at all scripted. There are a few pre-prepared links and things like that, but basically it's off the cuff. And sometimes our advice is no good and we make mistakes. Sometimes it's brilliant and you know, you act upon it incorrectly, and that's not our fault either. You know, and that's generally what we're talking about. It's an unscripted, off the cuff conversation. So you take from that what you will. This coming session coming up is Wednesday, 25th of August, which is next week. We are talking about databases, data access, and object relational mapping, or ORM. Definitely one to come along and have a look at. I think Wagner might be up for this one. He's an expert on some of the stuff.
So I did check. I had a message from Wagner. He said he couldn't make it this morning, but he will definitely be on next week. Next week was actually a session he suggested, and so he said if you schedule it, I'll be on there. And so here he is.
Right. Well, he is Mr. X Data, so I'm glad he'll be turning up, because otherwise I'd have to talk about it. I don't know an awful lot about it. I use it and it's great, so that's a good thing. But definitely a session you want to look at next week. 1st of September, flying in the Microsoft Azure cloud. All very exciting stuff, and I suppose in a kind of compatible or competing sense, the following week is about exploring the Amazon cloud or Amazon Web Services, related because they're kind of competing systems, but there are some differences. And also Microsoft has just released Windows 365. For those of you who do or don't know what that is, it's based on Azure. So if you're thinking at all about things like virtual desktops and stuff like that, you know, it's probably worth looking at on Wednesday 8th. We're also on YouTube as well. Jim has just reminded us. So if for whatever reason GoToWebinar doesn't work, we're actually streaming out live to YouTube. If you look in the chat window, you'll see the link there. Click on that and you can have us in glorious Technicolor, widescreen, HD, and all sorts of exciting things. I don't know.
But no webcams there either, unfortunately.
Yes, with or without subtitles, I think, and some of those appear weird depending on the accent. We shall see. Bob is not here, so there is. But
Bob is always with us and amazing. So even though Bob may not be on the stream with us,
he'll be
we
around.
Appreciate Bob.
Yeah, Dr. Bob. I have to say, I told him this last week, but I learned a lot from Bob in my early days as a developer. Delphi developer. He's not going to be on, so we're not going to talk much more about him, but let's just say Dr. Bob, hero of his kind, really worthwhile checking out his site. You can follow him on Twitter, ebob42, or just go to his profiles, as you can see there. Wagner, he can't make it today, so we're also going to ignore his little slide there, but Wagner, a very good guy, knows a lot about Aurelius, Nextdata, and RemoteDB, which is all about next week's session, so definitely worth tuning in. If you've not seen Xdata before or used RAD server or anything like that, these are all middleware and ORM systems, very worthwhile investigating. If you're currently linking directly to a database like SQL Server or MySQL or something like that, then you're going to learn a lot more next week about the kind of middleware and the advantages you get from that. Again, we're not really scripted, but it's definitely worth popping on and having a look. And a person who is on the line today is Alistair
I am
Christie.
indeed.
He is indeed, yes. He's a famous New Zealand developer nowadays. That's how we'll refer to him. Delphi MVP, consultant, developer, trainer, presenter, and author. You really must go to his website, learndelphi.tv. Alistair's done more videos, I think, than all the other MVPs put together about how to do stuff in Delphi. He lives on a lifestyle block in New Zealand. I'm still very jealous of that. And I'm also jealous of his hair because I don't have any and he's got plenty of it. We should swap over. Maybe I'll get an Alistair wig. But hello, Alistair. How are you doing?
Good. Yeah, morning for me. Yeah, I'm doing well. Yeah, so yes, I suppose you've already explained about me, so we might as well proceed to the.
Oh, okay. Well, we'll go on there. I thought you were going to say something wonderful like, yes, my book's
out. So go buy my book.
That's the one,
yeah, go buy Alistair's book. If you haven't read it, it's definitely worth checking out.
Yeah, it's there.
Yeah.
Code faster in Delphi, and it's. I mean, if I would big up Alistair for a second because he's too self-effacing to do that. One of the good things about Alistair is every time you watch one of Alistair's videos, he will show you something, some tip or trick. Even if you are like me, an MVP, and you know quite a lot of Delphi, and you teach other people how to use Delphi, I guarantee if you watch some of Alistair's videos or read one of his books, you'll pick something and go, oh my word, I didn't know you could do that in Delphi. That's one of his really good points, I think.
That certainly happens to me as well. Occasionally people put comments, comments on YouTube and stuff, and you go, I did not know Delphi did that. I should make a video on it.
And it happens to me all the time. I'm like, oh, I really didn't know that. And then you think, oh, I could have saved so much time in the past doing these things, yeah.
Well, the reality is Delphi is such a massive product. It is grown so far and so much over the years. It's just not possible. You know, even Marco Cantu, I talked to him and there's things he's like surprised. It's like, oh yeah, I didn't know that, or I forgot about that, or whatever, you know, and it's just not something that any one person can keep in their head.
Well, I definitely can't. I mean, I've reached the age of life now where all the new stuff pushes out some of the old stuff. It's full up. So if I learn how to make a different type of cake or something, now I have to forget something like, I don't know, how to speak French or something bizarre like that, which is...
Well, cake is important, so...
Well, that's pretty much my theory, which is why I also should learn about exercise and stuff like that. And obviously, me speaking, it's Ian Barker. I'm sure you know by now. Usually on these things, I seem to crop up quite a lot. You'll see me blogging on blogs.embarcadero.com. I'm a software developer. I get up every day and write code, Delphi code. That's what I do for a living. That's how I earn my money. I also do some audiobooks. If you ever look me up on Amazon or iTunes or what Apple call their store now, because they keep is it Apple Books or something, I don't know, but you'll see me on there as well. And I'm a writer, I'm a poet, a published poet. Used to go and stand around in costumes and read poetry that I'd written or somebody else written, and an Embarcadero Delphi MVP. I was born in London, hence my accent. In fact, Marco is currently in Greenwich, and I was born a mile away from where he's taking photographs, which is slightly bizarre. But I now live in Dallas, Texas, which is normally baking hot, but it's pouring down rain today. And yes, I do claim that Delphi is my superpower. Follow me on Twitter, please. It's @punctuation, or go and to my website, about.me/Ian Barker, and see a scary photo of me. And also in the background is Jim McKeith. Everybody knows who Jim is by now, I hope. Chief Developer Advocate and Engineer for Embarcadero, long-time software developer. he's got so many languages he knows. And yes, he is one of the people, or the only person, I can't remember whether you were on a team there and you did it, Jim, but invented and patented the pattern and swipe to unlock on your mobile phone. So every time you swipe to unlock, it's partially Jim's fault, and he even has 2 patent numbers after it. So we can all blame him when it doesn't unlock and say, Jim, please. I know, he's not a multi-billionaire as a result of that, because unfortunately, the way these things work is if you're working for someone else, they get all the money and you get absolutely nothing out of it.
Yeah, I don't even get Christmas cards for it.
Do you really?
No, I don't. Yeah, it was interesting. I've probably shared this before, but I had kind of forgotten about that patent and saw a blog post that was saying Apple didn't invent swipe to unlock, Jim McKeith did, and I'm like, whoa, that's my name. Yeah.
I mean, we've never
my
really talked about how it
was,
came about. Actually, I was going to say it's.
Oh, what's that?
And we never really talked about how that actually came about, how you did end up inventing that.
Oh, so I was working for a computer company, Micron PC, which was a subsidiary of Micron Technology. Micron PC is now gone away, but Micron Technology is one of the top memory chip manufacturers in the world. Most likely, a computer within arm's reach of you has a chip manufactured by Micron Technology. They're one of the top 4. It depends on, it varies from time to time who's the number 1. But they're based in Idaho, where I live, and they had a PC company, Micron PC, that was a subsidiary. And I was working for them, and they had a patent program where they encouraged engineers. I think I was actually in tech support at the time when I found out about it, was doing this one. No, wait, I was in engineering at that point. So I found out about this patent program. I'm like, oh, that's great. And so the way it worked is that if you'd write up a disclosure of a invention, and you had to, in order to get a patent, you have to describe it in a sufficient way that it can be reproduced. So there's quite a bit of effort goes into putting together a patent disclosure. And originally I had a patent for, I don't remember. My original disclosure was a little different, but it then changed into drawing geometric shapes to authenticate yourself to a computer. And using various pointing devices and stuff. And so the way patents work is you have like, here's this part, a pointing device can be defined as this permutation of things, and then geometric shapes can be defined as this permutation of things, and that included touchscreen and drawing a single line, or with the pattern unlock, any other geometric shape really. So yeah, that's kind of how it came to be. And it was interesting. I had moved since I was working for Micron, and I get a call one day from FedEx, and like, oh, we've got a package we're trying to deliver to you, and we got your old address. What's your address? And it's like, give them my new address. And I'm like, oh, who's it from? And they're like, it's from Micron Technology. And at this point, Micron PC was gone. And I'm like, what in the world would Micron Technology be wanting to get a hold of me for? I'm like, it must be a patent, because I knew some of the patents got assigned to Micron Tech. And I was going camping that weekend, and it was like a Friday. And so I go camping, and I come back, and it's Monday, and I see this blog post on my news feed that said, Apple didn't invent swipe to unlock, Jim McKeith did. And I'm like, what? And then I look at it, and I'm like, oh, and I look, and I have the FedEx package that came that morning, urgent next day air or whatever. Even though it was, from just across town, it had to fly to the FedEx distribution center, I'm sure. So I get it and open it up, and sure enough, it's for an extension for that specific patent, because this was right in the middle of the Apple Samsung lawsuit, and everybody was very concerned about this stuff.
That is so weird. I mean, see, I know if someone said to me, oh, there's a parcel from a former employer, my first thought would be, what did I do wrong? I mean, like, oh, something bad happened. Something has gone wrong. Yeah. Especially if it's a courier, and it's probably legal. Yeah. Right. I mean, we joke about it and things like that, but it's kind of a cool thing, to be able to say, oh yeah, swipe to unlock. Actually, yeah, I came up with that idea. It's and it was unique enough that you can get a patent, because patents are viciously complicated. I've invented a few things over the years that have been given software patents, which is slightly different, but but certainly my involvement with patents has always been so tediously legal and complicated, and trademarks and things like that. You've got to use them in a particular way and repeatedly. I used to work for Dictaphone, and they had a person there whose entire job was to write to people every time they were on TV and use the word dictaphone when they meant dictation advice. I mean, he used to say, "Oh, I remind you, it's a trademark." But there you go. Anyway,
so the interesting thing about trademarks, and not to digress too much into legal conversation, is that if you don't enforce trademarks, you lose them. So,
correct. Yeah, that's why the guy Dictaphone existed. He had to challenge, or at least mention to every single person that used the word dictaphone, that I would like to remind you that Dictaphone is a registered trademark of the Dictaphone Corporation International. And that was all he did, just wrote to people. But if they didn't do that, eventually they would lose the trademark. So, and ironically, they basically don't exist as a company then, but I was their first IT manager. And so I was kind of involved at weird board levels, as you do when in the days when computers were still being, brought into business. And this was one of those. It was a remarkable time, really, to be alive. These things nowadays they're all automated, and there's big AI systems checking things out and stuff like that. But this poor man, he sat there every day going through piles and piles of paper and writing to people. There you go. Anyway, we digress a bit, but that's kind of what we say TCoffeeAndCode is about. Just to let you know that coming up on August the 30th is the summit for the desktop first UX summit, actually. August the 30th to September the 3rd. There's some really, really great speakers involved. I'm doing some stuff, I think. I can't remember. But a few.
You better be.
Yes, yeah. I think, I'm co-opted in. I think that's how it works, right? But no, I mean, it's one of my favorite summits. It's very much a subject that I definitely believe in. And in fact, I've written several thousand words just recently about exactly this subject. But if you are not already registered, go to summit.desktopfirst.com. The link is on the screen there, and register. It's completely free. Although Embarcadero are sponsoring it, and I think Idera have some involvement in it as well. Jim, you'll probably correct me if that's wrong, but
yes.
Yeah, exactly. So there's a heavy involvement from us, but it isn't just Embarcadero focus. So if you think that it's all going to be about that, it really won't be. It's more about desktops and the idea of designing really for a desktop first rather than a mobile first. I was going to say theology, but ideology is probably better. We'll give you some sound reasons why that's the case. So feel free to argue when that happens and tell us why we think you think we're wrong, and then we'll tell you why you're wrong. But anyway, go on to summit.desktopfirst.com and register for it. Book your free tickets. This is TCoffeeAndCode. So grab a beverage and relax, as we say here. Like some kind of hypnotherapist. It is streaming out live on YouTube, and there will be replays. Every week someone says, will there be replays? Someone is also saying that our handout link is wrong, Jim, just so that you know.
It doesn't work in Chrome for some reason. Let me see if I can fix it.
Yeah, we'll sort that out, but if not, it will be on the replay. The replays will be up on the Embarcadero YouTube channel, and they'll also be on the blog as well, blogs.embarcadero.com. Okay, topics: static code analysis, memory leak detection, code optimization suggestions, and code profiles, SQL performance, and profiling. Which of you wants to go first, or are you
actually, as this is TCoffeeAndCode, I want to digress for just one moment here again.
Sure. Good plan.
So Marco tweeted this morning. He's at Greenwich Meridian Zone. Greenwich. Yes, Greenwich.
Yeah,
and the Prime Meridian. And I was like, oh my goodness, that's so cool. So this apparently is not a time zone because you used to live here, right?
Yeah, I actually was born in Woolwich, which is just up the road, spelled exactly the same way, which at the end of it. Anything with which in it is from Old English, and it means where they used to make salt. Funny enough, there's a little factoid for you. But yes, I was actually born in Woolwich, which is just Greenwich and Woolwich are next to each other. If you can imagine a picture of the River Thames, and there's a big bendy bit in it, the big fat bendy bit at the top, that's where Greenwich and Woolwich are. And the Greenwich Meridian is called that meridian after the town of Greenwich. But it's not a time zone as such. You see GMT, which nowadays is UTC as well. And so Greenwich Mean Time is just really named after the fact that the time zone relates to what is noon on that meridian when it isn't summertime, because we use daylight saving times in the UK. And so at the moment it's British summertime. So it's not a time zone as such. It's a marker point where that time zone is derived from. Does that make sense? Or is that?
Yeah. So I just was pulling up on Google Maps. So that's not so crossing that line doesn't change your time zone then?
No, absolutely not. No, the whole of the UK is currently in British summertime. And
oh, okay, that's right. Yeah. Okay, yeah, that makes sense because it's in the middle. Yeah. Okay.
And if you just scroll your map to the center bit where it says Prime Meridian there, if you scrolled in a little bit further, my questions are in the way. If you just stop for a second, whoops, down a bit, you see where the area is around the Thames there. That's called the Docklands. So that is a very ancient part of London, and I actually come from around there. So that is my home pad, so to speak. Cool. Yeah.
I've always wondered if you are Tower of London. So I've never been to the UK. I need to go there.
Well, you see where it says Bermondsey there? You know, you hear about Cockneys and things like that. The Cockney is someone who was born within the sound of Bow bells. The Bow bells are the church bells in the Bow Church in Bow Street. And to be a Cockney, you have to be born within the distance where you can hear those bells. So that is definitely very much central in East London. Canary Wharf is now very much a gentrified area, just the same as, you know, say San Francisco used to become cool back in the day, and now it's really expensive to live around that area because of Silicon Valley. Well, that area of London used to be a very poor area. In fact, it's where Jack the Ripper used to work and things like that, and killing all sorts of people in the slum areas. The slum areas were destroyed during the Second World War, and then that kind of got rebuilt, and now it's a very expensive area to live in Canary Wharf. My father used to work there. The Woolwich Arsenal is just up the road, and he used to work in the Woolwich Arsenal, which is where the English soccer team Arsenal come from. So yeah, that's a bizarre little journey around England.
I was curious when you cross a time zone, how quickly does the phone know immediately and change it immediately, or?
Yes,
do you know?
It changed. Most of them use the GPS signal for the time zone. So if your GPS is sending down the signal, a lot of them will synchronize. I believe, I could be wrong because I'm not a phone guy, but it's come back to me presenting it. Let me just there you go, back to my screen. I believe that the phones do it from there. I know that computers don't. They use NTP, you know, network time protocol servers and things like that as well. But when I've traveled across time zones, and Alistair will probably know this better than both of us, because, you know, he's in a whole different time zone there, but I've always noticed it changes as soon as I get a signal. So I'm guessing that they synchronizes with the tower, and that, you know, the cell phone tower says, hi, you're in England now. If I fly over Germany and I land in England, it immediately changes the time. So I don't know how it does it, but it's voodoo stuff in the background, you know, some kind of.
Yeah, I think it is primarily related to the cell phone towers.
I think they get the signal from there. I mean, all I know, I mean, most of the time you're supposed to have your phone turned off on the plane. So, you know, I think I would probably notice it more quickly if I was actually, you know, had my phone on. But I am good and do obey the rules. I do turn my phone off. But
yeah, me too.
I mean, yeah, exactly. I mean, I've driven before from actually Milton Keynes in the centre of England, near enough, all the way over to Germany more than once. And as you drove along, you would just notice the phone had changed. So, I'm guessing it's through the cell phone towers, and it's when it synchronizes, I'm sure. But yeah, it's clever stuff.
So yeah, if somebody's in the questions that has actually like walked across the time zone line, I've always been curious as to like if you could walk across and you stay connected, if it just changes immediately, or how quick does it change? Especially like on the where it's the international date line. I don't know. That just sort of thing always boggles my mind. I remember as a kid one night staying up to watch the clock to see.
You can do that in Arizona, because Arizona doesn't have daylight savings time. So this is for non-Americans. Most of the United States has, I think we have 5 time zones. I think so, something like that. I'm in the central time zone, so is Jim. But Arizona it never changes. So for half the year we're like 3-hour difference. For the rest of the year it's 2-hour difference or something like that. Very bizarre. Someone says,
let's get back to the main topic here.
We're just not talking about the subject. Yeah. Sorry about that, Gary. We got on and did some other things as well. So, okay. So we were going to talk about optimization and stuff like that. So who wants to go first?
I can talk a bit about static code analysis if.
Go for it. You'll be the hero, and Jim and I will be in trouble.
Yeah, do you want to go to the next slide? I think it's probably got the
this one.
Yeah, so we talked a little bit about this last week in terms of code quality. I think that was the topic.
Sure.
But there's a lot of optimizations in your code that can be made just by having an algorithm go through and analyze the source code. So it built into Delphi is the audits, which I have to say I don't use very frequently. I find the user interface a bit difficult to use. But certainly Pascal Analyzer, Pascal Expert, and Fixed Insight are all fantastic tools. There's the light version of Pascal Analyzer is free, so I just recommend go ahead and download it. It has fewer reports available than the full version, but it can point out a number of optimizations. And let me just. So the things. It's one of the latest slides. It's got a number of these, but things like using inline variables, which is new in Delphi. Certain types in Delphi require initialization, such as strings, and if you use an inline variable, you can shift that initialization into like an if-then, so it's conditional, and so rather than that initialization occurring every time the function runs or method, it only runs if certain conditions are met. So that's a pretty minor optimization, but can make a big difference. Also, things like adding const to your parameters.
Yeah,
that can have
that's my favorite trick, actually.
And it can make a huge difference if you're passing around records, for instance, because you might have a record that might be quite sizable, and if it's being passed into a function that's called regularly, then they can make a significant improvement. So that's a sort of analysis. The kinds of static analysis. Both Pascal Expert and Fixed Insight Pro both have similar. I think they do the same list of optimizations. So either one of those, if you got those, and they have trial versions as well. So absolutely no reason for you not to go and download the trial and run it on your code. And I could almost guarantee you it'll find stuff that you should changes you should make.
Yeah, I mean that's been my experience. That just when you think you're doing well, you suddenly go and use one of these tools, and you think, oh my, I don't know anything.
Yeah, particularly manually finding these things to optimize is just painful. You don't want to do it.
Yeah,
it's better to have have a tool do it for you, and then I don't think any of them make the changes for you automatically, which is would be nice. But they'll definitely point them out to you, and the Pascal Expert and Fix Insight both are IDE plugins, so you run them and they produce a list of messages, and you can double click on the message and it'll take you to that bit of code, and you can then make the change. Whereas Pascal Analyzer is more of a generates a report, and you can have that. There's a command line version of Pascal Analyzer as well, so you can do things like output an XML file, and then you could parse that XML file as part of your commit, source code commit, and then you could then potentially reject a commit based on certain things. Such as optimization.
So we've got any links for these? Let me just see if I can find one.
So Pascal Analyzer is for Genza.
I found them. I'm going to put that in the chat window for those that need to know it.
Yeah, and of course TMS Fix Insight is.
Fix Insight's incredibly. Actually, these are incredibly useful. It's like you said, it's amazing the things that it catches. For the thing that I think is classic that I know Fix Insight does, and I'm sure the ones do as well, is when you're doing a format statement. If you're the string inside the format statement, if the number of instances and the types don't match the array you're passing to it, it will warn you about that. And that's one of those things that if you don't run the code, you don't know that is wrong, but it will fail, right?
Yes, and it's quite often the weirdest thing is, and actually this goes back to tests, I suppose, as well, but it's usually things that you hardly ever display, error messages and out of space warnings, or some kind of thing where you're saying, hey, you're limited to 1 million records in this database and you're at 999,007 or something. And of course, those messages hardly ever come up. And when you test them, they work absolutely fine. But with something like that, where it can actually check those strings, because you tend to pull in the information into a format string and then display it that way. You know how many times you get emails where it says dear and then some kind of weird placeholder. And you're like, you didn't test your code, did you?
Yes, I think there's an instance of a UK bank that sent out letters to their big, clients. It was, dear rich bastard, because that was their test string, and that wasn't actually the problem. It was all the people who thought they were big clients and didn't get the letter that caused them the most grief. So.
Oh no, because then when the news got out.
Yeah, because
I've read places before where they make a very big point that not to ever put anything, even code comments that may not be, test data or anything like that. It must all be professional, because sometimes things leak out, unfortunately.
Yeah, and guaranteed, the more embarrassing and inappropriate it is, the more likely it is to happen. I remember we had a backup once, and this is another thing that you can't really test, but we were doing some kind of weird backup at a customer's site, and it showed the directories as they were being compressed. And unfortunately, one of their members of staff had a habit of making the folders with obscene names, and it wasn't anything. It wasn't containing anything other than text files, I think, or something random like that they were backing up. But all the customer saw was a screen full going past of obscene names for these folders, just because the guy, instead of saying temp1, temp2, just picked some random name. So you never quite know when these things will surface themselves, because it was embarrassing for us, because obviously we were on site and the customer was standing over our shoulders like, why are you making those messages appear? And it's nothing to do with us. It just happens to be your folder names. It's one of those things. So I put in the links, a couple of them. So Pascal Analyzer, Paganza, which is one you mentioned, and Fixed Insight from TMS as well. Pascal Expert, what is that?
That's also Paganza. So that's their, IDE version of Pascal Analyzer.
Browser. Yeah, that's right.
As was pointed out in the conversation by Martin, SonarQube actually has one now as well for Delphi.
Oh, really?
Or static code.
Yes. Yeah, I remember seeing that.
Yeah, I mean, there's a lot of stuff available for this kind of static analysis, and also for gotcha catches where you've done something horribly wrong by accident. It's fantastic stuff, really. And I don't care how experienced you are, sooner or later you're gonna make a mess of these things, and stuff like that. This is what separates the professionals from the non-professionals sometimes, is the amount of additional work you do on top to protect yourself from.
And also it's worth noting that you might be really good at programming now, but there was a point that you weren't good at programming, and a lot of that code might still be out there.
Well, last week, you mean?
Yeah. So I've been analyzing a project that I've been working on for 20 years or something.
Oh, and, I never.
And yeah, just some of the code is that old. It's really very cringeworthy going over that again. But yeah, it's just mostly just missing trifinalies or a malformed trifinally or something like that.
And also I've said this before. In fact, I think when we did the fireside chat with Jim, actually, but for me, I've been a developer for 37 or 38 years, I think, and over that time, it's been long enough that I've seen fashions in coding change. You'd never think there'd be such a thing as a fashion, but there really is. And object orientation obviously came in fairly sort of about a third of the way through that career. It was around, but it became more a prevalent kind of way of developing. Really, relatively recently in terms of development. Probably 20 years, something like that, maybe 15, before it really became well adopted by lots of different languages. Up until that point, that wasn't the case. Definitely was not. There were lots of systems. There's one called Jackson's structured methodology. I don't know whether any of you came across that, but that was something they did for COBOL, where they tried to almost make it object orientated, and it wasn't really. It was just an overcomplicated form of flowchart, and everybody ever saw use it failed. But these are fashions and trends, but some of these trends are so worthwhile that they stick. And I think, you go back and look at some of your old code, and whilst it's embarrassing, actually at the time, it might not have been. It might have been, people would have been carrying you shoulder high through the office going, wow, he did so well, really. But now you look at it and you think, I really must go and lie in a hole somewhere and hide.
I remember when object-oriented programming was coming around, I was still in school, and I would argue with people that I did not see the point of object-oriented programming.
Well, it's weird. It's an abstract concept, and that's the thing. It's one of these things where once you start using it as a developer, then it makes sense. So you understand why. Whilst we're on the subject of tools, ProDelphi is another one. This is a bottleneck analyzer. I like this tool. It helps you find a lot of things that the other tools that we've just shown there found as well. It does it by you run it against your code, and then it puts in a microsecond level timer. So you can say things like, wow, this particular routine here, that's why my program takes 4 seconds to launch. It's because of this particular section here and things like that. So it's a bit like an analysis tool, but it does a lot more than that. But it's really a glorified timer as well. Very, very useful. I've used it in several projects and made a big difference to optimization. So, it's written.
This one is a runtime analysis, whereas the other ones we're talking about were static code analysis, so static code analysis look at the code itself. So they are before your program runs.
Yeah, well, it does both. It does do static analysis as well, but the idea behind it is that it combines the two. It's more implementation. So the instrumentation will come back and say, yes, when it ran, this bit took this long to fail or succeed or, you know, retrieve the first record or whatever. So it's pretty good. You know, I think, I don't know about Alistair, but I think you usually end up using more than one tool. I think that's my experience.
Yeah, absolutely. And yeah, I mean, I've actually never used ProDelphi as a. I said I think I have. I might have tried it out at some point, but
right.
I've used some of the other code profilers in the past,
Right.
but not for years. I've not really had to write anything that's required a huge amount of performance. There's a couple of routines that I needed to optimize, but I wrote basically, you know, timed the code and just iterated on modifying it until it got faster and faster and faster as I improved the string manipulation that was going on.
Yeah, when there sometimes there'll be times where you know where the bottleneck is, but when you don't, then one of these tools is invaluable, just to help you track that down and discover it.
Yeah, I mean, a lot of these profilers will also tell you about memory leaks as well, but I think we're getting ahead of ourselves in that respect for one of the later slides.
Yeah.
Actually, so I'm going to switch to
my slides. Actually, I don't know what I've done with them.
I'm going to show my screen here.
Sure, you do that. I'll happen to my slides.
So I have Fix Insight installed here. The apparently the trial version. I need to put the license key in. But so this is a list of the settings on here, and here's the warnings that you can get that it'll add, as well as optimizations. But here's the, let's see, odd else if conditions, empty else block, empty missing inherited call constructor. So basically what this will do is this will tell you when you are violating one of these, or when your code is doing something here that this detects as is potentially being suspicious free call. And I love that they have the text here that describes it for you as well. Unreachable code, and it shows up. Let me.
I love it. Says suspicious.
Yes. Yeah. Well, and see that's really the thing is that a hint. Well, hints. So that's hints and warnings, right? Hints might be an issue that they're suspicious, right? But then warnings, it's like, that's probably wrong, but it technically compiles, right? And that's the difference between a compile error versus a hint versus a warning.
Yeah, I think last week the consensus of opinion was hints and stuff like that. Really, you should do what you can to get rid of those.
Because, yes, I totally, absolutely. So agree. So this code.
It's one of those things that get called a bad smell. You know, when in a project. I think it's not a bad analogy, really. That I don't like that when people say, "Oh, there's a bad smell about this code," but actually, in some ways, there isn't really a more appropriate metaphor for it. It's just basically, it looks okay, but something seems off. You know, and so you know that's where that's coming from. I think.
I guess I have to put a
percentage or something.
Yeah. So this will compile. But then when I run it, we get an error. But then Fix Insight project, Fix Insight. That didn't give me the message. Why is this empty? I haven't used Fix Insight in a while, but let's see. Maybe it's because I'm in the trial version. Normally, we give you
could well be that you've got fewer checks going on.
All right. Well, let's disabled in trial version. Yeah, so some of these are disabled in trial version. That's why. That's such a good. I'll punch the code in here in a second when I'm not in the thing. But then I also wanted to come in here and show. So I'll open up. This has got some code in it. A little bit. Okay. If you come in here to, I was just in here. Project, is it? Yes. So you have different ones here. You have the method toxicity metrics, which
favorite analysis. Yeah.
Yes. This one. Let me get a different project. I thought the one had more meat to it.
Yeah. So whilst you're finding that, someone's mentioned, who was it? Martin Sedgwick mentioned Stefan Glienki, who he has ported a Google micro benchmarking tool to Delphi.
That's right.
And the problems of micro benchmarking, great resource. Delphi source3.blogspot.com. You should see that in the question mark window, questions window there for everybody. Stefan, very, very smart guy. Got a lot of respect for him. Him and there's a couple of other MVPs who worry about things like CPU instructions. Or this command will take 2 extra CPU instructions. I never ever think like that, but I'm glad there are people that are out there that are MVPs that do think about that. They're very vocal on things like beta forums and stuff like that, where they say, "Hey, you could have done this with one instruction." And I just think, wow, I'm happy if my code compiles and runs. I guess there's every type of programmer around, isn't there? But yeah,
yes,
very, very smart people. Thanks for that, Martin. Appreciate it. Bruce McGee says, "Beware of thinking you know where the bottleneck is." Yeah, not wrong.
No, that is true. That is so true. So yeah, this is okay. This is a good one here that shows some more data here.
Yeah, that's cool.
Yeah, that's certainly more code quality than optimization. But if you look at you know, the cyclomatic complexity and code, the length of the code, that might also give you an indication as to what methods might be an issue in terms of.
Well, with the Pro Delphi as well, the interesting thing about that tool is that it comes back and tells you which bits of code aren't being used. Because obviously, if there's 0 usage and you think it's something that's being used a lot, or the other way around, something that's being used a massive amount, it kind of falls into the remove redundant code area. And cleaning up your uses clauses and things like that as well is quite important. The compiler is an optimizing compiler. People say, the more usage you put in, the slower it gets. Well, that's not strictly true, because the compiler does optimize out things. Actually, it's the linker as much as anything.
It's still going to do the analysis though. So
exactly, and that's the point, that some code might be called theoretically, or the compiler or the optimizer gets it wrong.
I mean, if you've got an initialization block or something like that, then the compiler can't remove that unit. It might be able to remove parts of that unit, but that initialization still needs to be called.
Well, the classic thing is data modules and things like that. I saw a guy recently. I worked with a guy who he'd read someone's book, and I can't remember whose book it was, but it might have been no, I can't remember, Pavel's book or something like that. But he basically decided to add caching for the databases. And he did a very good job of adding the caching to it, to this database system, in terms of saying this would make the program go much faster, definitely much faster. But the problem was that he didn't actually test it, or didn't test it correctly. And what actually happened was that most of those database calls were very simple, and Delphi itself was actually already acting pretty optimally. And so all the methodology that he put in for caching the system, so to speak, slowed everything down. And it actually took, on my initial test, 4 minutes to load the program. And I went through and optimized the code, and I did actually use some code tools that we mentioned here to do that. And it took under a second to load. Same program, same data, same screen, time to screen. So sometimes really, if you don't understand the techniques that you're using to try and optimize things or to speed things up, you can actually make it worse. And this is a case of, in point, where adding the caching was not an optimal solution. optimal doesn't mean clever. It means the right, the right technique to pick on. And in this particular case, unfortunately, this guy did not do that, and it was a bit of a problem. And unwinding his code also was even worse, because it was some of this very tricksy code. There's a lot of clever, tricky stuff, and unwinding the code without breaking other things became quite difficult. He wasn't around, by the way, otherwise we would have asked him to do it.
Yeah, I mean, it's the whole premature optimization.
Exactly.
Yeah.
It's write your code. You should always initially write your code for readability, and then.
Yeah, he'd read a book, and I'm not trying to. I don't want to mention his name. I don't want to denigrate him personally, but what he did was his intentions were good, and he was a good programmer. A lot of some of the other things he did were really excellent, but some of these particular bits and bobs, you look at it, and I could have throttled him. If I could have physically got hold of him, I probably would have destroyed this. And why did you do that? And it was all like, hey, I use it. And he commented where he got the routines from as well. So I kind of knew where he was aiming at. But yeah, if you'd use thought about optimization rather than best practices and trying to do some caching and stuff like that, the system works very well. FireDAC, for example, got some extremely good back-end mechanisms that you don't always know they're going on to speed things up. So
yeah, I mean, I can mention I had a project that had it was displaying a list of records, and one of those records was a comma-separated list of codes. One of the fields was a comma-separated list of codes, and it had a calculated field which expanded that comma-separated list into what those values actually meant. And so basically that calculated field required looking up in another table and doing a whole bunch of locate calls. And I replaced that with that lookup table with a dictionary, a hash table, so using T-dictionary.
Yeah.
And I got about 1,000-fold improvement in performance doing that. So that's caching can be quite valuable when done properly.
It's one of these things where you read a lot of stuff about people going for technical interviews at Google and stuff like that, and being asked about computer science type things like binary search trees and stuff like that. And it's caching and understanding what is the optimal path for anything really is one of those computer science things. Actually, it's one of those things where if you didn't study computer science, then you're probably gonna have to read a book about some of these things, because they're non-obvious. Like hash tables, it's an abstract idea, but it's used repeatedly.
Yeah, I mean, talking about computer science, we're going for the big O big O notation in terms of algorithm performance. Looking up in a table is it'd be log n performance, probably would be based on an index. If it's doing a linear search, it's order n, and a hash table is order 1, so it's via a constant. And if you don't know what those mean, if you're looking at a lot of data, then an order n squared algorithm such as so bubble sort, for instance, you replace that with that uses a n log n, such as merge sort or quick sort. The difference in performance just becomes, going from this would take more time than there is left in the life of the universe to a few seconds. The really obscure, arcane sort of computer science stuff, but it is definitely worth knowing and being aware of these things.
The way I look at it is like this. Okay, you don't have to have completed a computer science degree, but you do need to know some of the concepts, and that means either being autodidact and teaching yourself, or going on a short course, or looking at some of the teacher websites that are around. I can't remember all of them, but LearnDelphi.tv is one good site where you can learn some of these things. But if you don't understand some of the principles, it's like trying to analyze poetry that's written in French when you don't speak French. Because what can happen is that you can look at a French poem and think you understand what's going on because you can see words that look like they rhyme, for example, but actually you might not understand the nuances of why the poem is good or bad. And it's the same thing with an algorithm. If you don't understand what's going on behind that algorithm, you can look at it and how are you going to go and change it if you don't understand exactly why it does certain things in certain ways? You know, and it's French poetry, you can't go and change it if you don't understand it in the first place. Same thing with some of these routines. So I'm not suggesting that people go out and get a degree, otherwise they're useless, because that's definitely not the case. But I am saying that there's some things that you do need to go and study up on, you know, particularly if you work in teams, because once you start to work in teams of people, then you'll very quickly get involved in conversations where you'll just think, oh my word, I don't know anything. You know, what on earth are they talking about? Like big O notation, there's a classic example. It's one of those things where until you've heard of it, it sounds like you're talking about some kind of 1970s manual for husbands and wives or something. The big O notation. But yeah, it's useful. I noticed on this list one other thing about optimizations is, and kind of, I don't know whether it's a generic thing, but ironically, generics are another thing where if you use generics all the time and you don't know why you're using them, but you're using them for the sake of it, then you can very quickly create a problem, because generics are relatively slow compared to I don't know, the basic types of things. And sometimes doing something with a little bit more code, but not using something like a generic can actually pay off. But if you use one of the tools that we sort of listed there, it will actually give you some insight into whether it's optimal to use something like generics or not. You know, is there something more concrete useful? I see so much code that's very clever and uses, you know, RTTI and generics and you know, slightly more advanced techniques, and yet if they'd run some of the optimization things, they'd realize that actually it isn't always going to be helpful. If your program's very small, then, you know, sometimes doing it the hard way or the longer way is actually quicker. It's a good compiler. It does lots of optimizations, lots of linking.
There is something that's kind of counterintuitive sometimes, is that so I was working with a guy once that was doing some high-end graphics and stuff. It was really cool. It was every day I'd come in and be like, oh, look at that, I got this going on here, you know. And he was doing a page turn effect and actually got some of the math wrong, and it did this like weird ripple, and decided to keep it in as an option. It was an inverted page turn, but he was doing like stuff like unwinding loops and stuff, which is like really things I wasn't like familiar with why you would do that. But then since then I've learned that. So the idea behind unwinding loops is that sometimes if you have a small loop, it makes sense to just do the code iteratively, right? The statement multiple times, write the statement out multiple times instead of putting it in a loop, because adding the loop is some overhead because there's jumps and stuff like that. And so
yeah, certainly like if you've got if I equals 1 to 5 kind of thing, I is assigned 1 to 5, you could break that up into just a big block of code.
Exactly.
Repeated 5 times.
And it's, you know, it's the same thing happens with databases too, is that there are, you know, we try and make our data normalized, but sometimes you want to denormalize your data for database performance, right? Or something.
We do that a lot. We do that a lot.
Yeah.
Because we're dealing with the human resources programs, you can very quickly get lots of normalization issues, because you don't want to give someone a whole bunch of data just because you want to produce some very small amount of information. So we have some fairly draconian laws about personal data protection in the United States and in the UK and Europe in general. And first order normalization and other techniques where you're putting things into different files is actually very useful, because you can, you know, give someone some information and the reference is database table that they've not got access to. So all they can see is the non-specific information. But other information is the exact opposite. You actually want to include some information in there so that they don't have to do lookups into tables that you don't necessarily want to give them rights to, or even have in the same country, which does happen. It's a bizarre thing. So yeah, it's an odd situation. My wife is talking to the dogs in the background. It's very bizarre. Local subprograms with references to outer local variables. Okay.
Yeah, so these are some of the things from the last. So inline variables, virtual methods not overridden, down to the inline subprograms, sub procedures. Yeah, they're all from Fix Insight and Pascal Analyzer, or Pascal Expert. So these are kind of the things that come up. And some of these optimizations are going to be might be relevant to you, and some of them might not be. If you're wanting to, make very small improvement in performance, maybe these things are irrelevant. But if your application is taking 10 seconds to start up and you want it to take less than a second, a lot of this stuff's probably not going to help you. You probably have to look at some of the bigger stuff, such as when you're initializing things. Are you creating all your forms when your application starts, for instance, where instead you could create them as required? What tables are you talking to a database where you don't actually need to be during startup? But yeah. But shall I quickly go through some of these?
Yes.
So just already talked about the initialization. So rather than creating when, say, your application starts or when your form is created, you could, if you have something on a form that's on a tab that's not being displayed initially, you could, maybe that's displaying some data from a database. You could have that data be loaded when that tab is shown instead. So yeah, you want to push back
memory tables.
Push back as much as you can to when it's required, rather than when it starts up. So it's kind of
there's actually it's a balance with that too, because if you wait until it's required, so typically there's an interesting thing about the types of applications usually we're developing with a user interface. Now, this, of course, not everybody develops this type of applications, but usually there are times a lot of times your application is just sitting there waiting for the user to input. And so
yes,
ideally you want to wait after the program initializes and comes up, but before the user needs it, right?
Yeah, so that's the third option there, the parallel programming, right? So you're looking at what can you do in the background or in parallel. So yeah, doing stuff in the background thread and that kind of thing, as you say, is generally applications 99.9% of the time sitting there waiting for the user to do something. What can you do during that sort of downtime?
Conrad Vermeulen, I apologize if I'm saying your name wrong, says generics has nothing to do with speed, but using types generics can make the code a little bigger because the generic types are expanded with the generic parameters, but that does not make the code slower. I disagree. I do hear what he's saying, that he's saying you can make a program bigger because you're including quite a lot of units and code that are there to support generics. But I disagree. I know from experience that using generics in some circumstances is slower. Not always, and I think if you start, having a big enough program, then generics actually can make things a lot quicker, and certainly can help make your code more testable and more divorced from concrete classes and things like that because you're using generics. But saying that generics aren't slower, it just depends on your use case. I think that's my opinion. I mean, he may be right, Conrad.
So this goes back to like I was talking about, the unrolling loops. So sometimes you optimize for less code you're writing. but that might be generating more code for the compiler, for the CPU, the disassembly. And sometimes more code for the disassembly is faster than less code because it has less jumps in it. And so the amount of code you're writing doesn't necessarily translate to the amount of instructions generated. But sometimes more instructions can mean slower as well because there are more instructions that need to be covered. And so this is one of the things is that a lot of times we're like, well, what is the right answer? Should I use generics or not use generics? Or generics fast or generics slow? It depends. I've taken an interest to this YouTube channel. I think it's called Legal Eagle, that he does these legal analysis of things, this lawyer. It's kind of fascinating. And 90% of the time, the answer is, it depends. And that's really the same thing here, is that so often it depends on so many things, and it's just really hard to make a generic statement that's always correct.
Yeah, if code optimization was a Harry Potter thing, it would be Slytherin, and it would be in the dark arts class. Because optimizing your code can make your code ugly. Optimizing your code can make your code difficult to understand for developers, but it can improve your actual application. So it's one of those things where it's a dark art, because if you go too far, yes, you've made an application that is 7% quicker or something like that, but every time you come to maintain it, it takes 30 times as long. So it's sort of horses courses. The thing about unrolling loops, which is actually a very good example of optimization that's non-obvious, I think, was there used to be I can't remember if it was Delphi and if it was an old version of Delphi, but if you debugged certain for next loops, sometimes the optimizer would optimize the loop in reverse. And so you'd go stepping through this loop and the counter would actually count backwards. I'm sure it couldn't be Delphi because it must have been some other language, but it was just the way the optimizer decided was the order of the loop counter didn't matter to the actual output, and so it made more sense to decrement some kind of register or counter or something like that. And as you're going through debugging it, it looked completely bizarre because you're saying from 1 to 10, and it actually counted from 10 to 1. And it's the reverse loop. It's just bizarre optimization. I think people that write compilers must be slightly insane. I don't know how they do it, because they must sit there and think about things that you or I or anybody else must never ever think about. They can write code that just baffles me from time to time.
That's kind of like, I mean, really, us as programmers in general are in the same boat. Is that I've had so many times I've had a conversation with a customer, right, the end user of a software, trying to capture requirements. And they're like, oh, well, this is what this works. I'm like, well, what happens if a user does this? They're like, oh, they wouldn't do that. I'm like, okay, so we don't let them do that. Like, no, they might want to do that. Okay, so we let them do that. They might do that. What would happen if they do that? They should never do that, though. Okay, so we don't let them. We have to think through those scenarios more than the average user does. And then it's one of those things. Each time you move further down the abstraction layers of abstraction, you have to think deeper and more archaic, I guess. I'm not sure the terminology would be, but more esoteric. Maybe that's the term. And it's more, you just have to think about different things. And so there is certainly that happens. I know there's times I've written code where I've used a reverse loop because it was faster, and I can't remember the reasons offhand.
Or a while loop or something like that.
Yeah. So
when we're talking about inline variables, I have to say I personally resist using them, and that's a personal choice. I have used them, but inline variables to me was when Delphi stepped away a little bit from what Pascal was all about originally. And I don't have a problem with it, but it was just, I looked at it and like, initializing things in the middle of statements is one of the things that C# does and confuses me. And the other thing that C# does is has await everywhere, just like JavaScript does, and I get why they do it, but inlining of variables can make the code a lot more clear as long as it's used correctly. And the trouble is, I think we haven't reached the stage yet where there's enough mature Delphi code out there with inline variables for people to go, that's a good idea to do it that way, and that's a bad idea to do it this way, that kind of thing. And I just think there's potential for confusing everybody. You know, oh, the variable's gone out of scope. How do you know? I just know. You know, it should be obvious. You know, I liked the fact that you used to have to declare the variables somewhere else in Delphi. It was, you know, malice aforethought when it came to variables rather than, yeah, as it went along, you know, declaring them then was tricky.
I have to say, I find inline variables quite helpful, particularly in that.
Well, now we're never ever going to agree.
Yeah, well, but you can just type, you know, you have some function that returns something, and you just type, you know, var x assigned this function, and it just picks up the type automatically. You don't have to remember it. And if it's a function that you don't use regularly, then, you know, you're not having to go through the code and find, oh, what does this return, and all that kind of stuff. And it just automatically, and you still get all the code insight and stuff for that variable. You know, it's because it is of that type.
Yeah,
at design
I mean, I know I'm being awkward when I say I don't like them.
Yeah,
I actually will end up using them.
Certainly, I have been skeptical. I'm still skeptical about using it. But, you know, I'm certainly experimenting, and there's quite a few. I just keep coming across new little use cases where it's actually quite handy having, you know, inline variables.
Yeah.
So, but yeah.
Well, managed records are another example of you know, newer technology, I suppose, where you know, having initialization and finalization and things like that is actually quite important for certain types of type, I suppose, or data. I don't know, you know, it's I'm not completely against it. I'm just saying right now I haven't been fully sort of immersed.
I've
you know, I'm an old-fashioned.
Yeah, I've not used you know, a managed record yet, so I you know, I've made a video on it, but
yeah,
I've not had to use
saw that video. Very good video, actually.
Yeah, no,
yeah.
Thanks. Yes, I need to do part 2 of it, but yeah. Yeah,
well, it's all, you know, I don't know if you're anything like myself, but there's always something else to be doing. I always have 50,000 things I need to do yesterday. I know Jim's like that as well. Yeah, the more you do, the more you seem to need to do. It's one of those things. So
I always want to do everything, and unfortunately, I just can't. It's life.
Yeah. Well, Chris Peters, he said, by the way, Chris Peters, what we would call a frequent flyer, is always on these conferences, always asks a lot of questions. So hello, Chris. I know Patrick's on here all the time as well. Patrick describes our TCoffeeAndCode sessions as his English lesson. Did I tell you this? I thought it was quite funny because Patrick speaks French. Salut, Patrick. And he says I'm his professeur, which means teacher in French. So I apologize if you're learning English from me. It's probably not the right place to learn it, but could be worse, I suppose. Yes, Chris says he's with me on the whole inline variables thing, so I do have some supporters in my resistance. I will eventually crack and use them liberally, I'm sure. And Conrad says they're also useful if the unit does not have to be added for the return type that is being returned. This can make life much quicker. That's actually probably the killer use for it, is as you said, you know, being able to not know or not have to know what the return type is. You create this var. It's a bit like variants, really, in some respect, in that way, where, you know, you just declare a variant and it returns something that works. A variance used to cause me all sorts of problems when I used to do Visual Basic. Back in the day, I was a VB guru, and you would often get code that would have to return lots of variants because it was talking to Windows SDKs, and VB didn't have the necessary base types to work with things. So it was always slightly horrible. I did for the return type. Yes, so that's a very good point. The non-return type.
There was a comment earlier about the parallelizing, making your code parallel, multi-threaded, actually can slow it down. So the reality is that parallel code is slower than serial code. if your program is just doing one thing, that adding multi-threaded support adds overhead, it will slow it down. But if you have multiple cores, or you have times the user doing something else and your program's waiting, then it can be faster because of the fact that it is able to do things while something else is happening. So adding multi-threading does slow it down, but if it's done properly, it speeds it up, makes it more responsive.
Yeah, I mean, anything with the UI and anything where you're retrieving data, depending on the database, of course, because not all databases work very well multi-threaded, but when you're trying to display something and do something else and do something else, it soon gets to the point where your program just freezes and doesn't really do much at all, and it all gets very horrible.
And then there's a question here about whether data modules add much overhead. They're fairly safe because they don't actually instantiate any additional resources and stuff, I believe. Again, though, I would say,
yeah, certainly use them in preference to a form for putting controls on, because a form has a Windows handle and all sorts of other bits and pieces that to a much lighter weight in that respect. But
again, you really want to do some profiling and testing to determine if you have bottlenecks and where they are. Willy-nilly saying, oh, well, Ian said that generics are slow, and removing all the generics from your code, you might slow your program down, right? Or if you say, well, Jim said generics are fast, and now switching everything to generics, you might slow your program down. You really need to create tests for your particular scenario and then profile your implementation.
Yeah, and horses for courses, as they say. You pick the right thing, and experience is hopefully picking the right thing, but I can tell you from reality, I still pick the wrong thing quite often. So I would say this to people, I mean, I know we're on here as the presenters and the broadcasters and things like that, and all of us, Jim is a special case of person, but all of us are MVPs, but that doesn't mean to say we have some magical powers about being right every time. I get up and write code every day, and I sometimes write really bad code, and sometimes I write code where people come and want to make copies of it and ask me how I did it, and it's just, that's the way it works. And it's really down to enthusiasm for the Delphi language as something that actually gets the job done. This is how I earn my money, is write Delphi code, and I don't have all the answers. And these webinars are as useful to me, and I'm sure to anybody else who's appeared as a guest, in learning new stuff. And the people asking questions quite often come up with some very good points that we don't know about, or we were misinformed about, something like that. So, it works both ways. It's a two-way street here about what's going on. Hopefully we impart knowledge you don't know, and then otherwise we're just sitting here and just talking a lot for 2 hours. But,
well, we definitely sit here and talk a lot too.
Yeah. Well, that's 2 hours of talking. It's pretty good. Okay,
I would say that there's a few more comments about optimization and such, and I'm going to add my philosophy is that there's like 3 stages to it. You want to have some sort of write some code, experiment with something, see how something works, right? And then you want to create tests, like we talked about last week, unit tests that test it in a specific scenario, and then you want to use profilers to profile your program. And the really important thing about this, and you want to be doing it over and over and over again, it should be part of your release process at least, is that sometimes things change, right? So you may have a third-party library that you get an update for, and they fixed a bug, but that bug was made your code slightly faster in this scenario. You weren't experiencing the bug, you weren't having the negative side effects, but because of the way it was written, it was slightly faster. So they added a check-in to fix that, and now it's slower than it was because they had to check for this error condition that some people were encountering, right? Or maybe the new version of the compiler changes the way something works. And so having those profilers running as part of your build process, having the unit tests running as part of your build process is really important to maintaining that knowledge that it is running the way you expect it to run, and it is as fast as it could be, or that you're not encountering unexpected bottlenecks. And way back in the day, we were building software. I had some of this database software we were using, and we had a customer that was connecting via satellite internet, which is still a thing. It's not as common, but they had a phone, a dial-up phone connection, and the requests would go out over the phone and then come back. The data would come back down over the satellite. And we discovered a whole bunch of scenarios where all of a sudden our program was incredibly slow because of that behavior. And what we had to do is we had to batch up the requests to the remote database, to the middle tier. And that's something we'll talk about next week when we get into multi-tier logic. But by batching up all the requests together and sending it out as one request and then sending all the data down as one result package was orders of magnitude faster for this scenario. It was marginally faster for everybody else, but it wasn't noticeable until we had that one customer that came on with the satellite internet. So you really just have to keep monitoring and testing and finding out, so you come here to this session, get some, wild hair in your head, wild idea about generics or whatever, test it, profile it, implement it, and then keep testing it and profiling it, and and keep going. It's an always evolving art. What is it? The Art of Computer Programming by
Donald Knuth.
Donald Knuth, yes. He's still working on that.
Yes.
What's that?
Yeah, he is. Yeah.
He's still working on it. It's not done.
Yeah, it's like is being released in parts.
It's the fifth or fourth bridge. They keep painting it forever because once they get towards the end, they realize the first bit needs repainting. So I think it's like that with the book. Ooh, thunder. Oh boy, we've got a thunderstorm outside. I must tell you something about satellite internet whilst you mentioned that, actually, because it's a very cool thing happened. Back in the day, we were looking at someone out in the field who was going to be using satellite internet. And we discovered the big problem with satellite internet was the latency of the initial connection, not the data arriving. So what would happen was it would take like 3/4 of a second to make the initial request for some data. But once the data arrived, it came massively fast. It was like great big fire hose. And so that was a problem that we had that. But the interesting thing about that was I actually went to a thing in Baltimore to meet one of the suppliers of the satellite thing. They were at some kind of exhibition, and the guy that was presenting the product was Buzz Aldrin.
Really? Oh my goodness!
Yeah, I got to shake his hand. It was absolutely. I'm sure he's shook millions of people's hand, but he was actually their spokesperson. I don't know whether he had an investment in it or something like that. It was a very long time ago. It was in the very initial days of satellite internet, but Buzz Aldrin was their speaker. Yeah, he was a really interesting guy and a lot smaller than you would imagine as well. But there you go. But he's still around, isn't he? I'm sure Buzz Aldrin's.
Yes, yeah, I believe so.
Yeah.
I met
getting to
95 or something, but. Yeah, very interesting.
I met him a few years ago as well. They actually, pilots and astronauts, they do favor shorter people because it makes it easier to fit them in the cockpit.
I used to know a guy that was a Top Gun pilot, and you always knew when he'd been working because he had bloodshot eyes. Because when they go around and they pull negative G forces, the blood rushes into their eyes because they're little pressure suits and things like that. So they always look like they just had a heavy night on the beer or something. It's quite a bizarre experience. But yeah, very smart people. You want to meet people that switched on, meet a fighter pilot or an astronaut. Those people really are the pinnacle of every system in your body working together all at once. And very interesting.
Back on top of satellite internet, I mean, that's probably with Starlink, satellite internet is probably going to become very, very common because it's you can have high performance internet out in the middle of nowhere. So I think
when we were looking at it, it was a long time ago. It was probably late
but
90s,
still latency, even at a low orbit, there's still going to be more latency, and that may have an effect on your application.
Isn't Google launching a load of satellites or Amazon or someone? And or probably Elon Musk, I'm sure, is doing something.
So Elon Musk has Starlink internet. I have a couple friends that have Starlink internet, and the thing that's different about Starlink is that it is a new constellation of satellites, but they're doing these. I can't think what they're called, microsatellites or something like that. They're smaller, like size of a bread box, roughly, satellites that are at a lower orbit, and because they're a lower orbit, the speed of light is fast, but the being closer, we're talking about big distances here, so being closer does make a significant difference in the speed of your internet. By the way, if you have not seen the KGB, The Computer and Me, which is based on The Cuckoo's Egg by Cliff Stoll, I highly recommend it. It's phenomenal. You can probably find it on YouTube. It was an old PBS special, and in it, they're tracking down this computer hacker back in the, I want to say, 80s. And there's a place where they go to test the ping time when the hacker connects to the network and discover that he should be on the moon because based on the ping time. They're like, that doesn't make any sense. And then they realize it was because he was coming in over satellites. And back then, when you connected over to the internet over intercontinental, you use satellites, and all the phone conversations, however, went on the transatlantic cables because those cables had lower latency than bouncing it off a satellite. But today, most internet traffic goes over those transatlantic cables as well because we're more concerned about ping times than we used to be. Interestingly, like financial people that do stock trading are trying to get offices closer and closer to the central place, the NASDAQ, right? So they can get that just slightly faster information from them. It just boggles my mind.
It can make a big difference. I guess when they're talking about automated trading and so, I mean, there's some code that you don't want to get wrong, because they're coding stuff that has got to execute in thousandths of a second, or it could cost the company millions, literally. And that's not the kind of code I would want to work
on. Capital to
oh my goodness,
find out how bad things can go.
Yeah, exactly. And
what happens when you leave
cryptocurrencies
code
to go wrong and stuff like that.
Yeah,
it's fascinating stuff, and I wonder how they do their testing and their profiling, because when you're talking about those kind of speeds where it's a thousandth of a second, latency makes a big difference to them. How do they test these things? Because we all know when you're running a debugger, things go slower because the debugger's got an overhead on top of something. So you can't, I suppose real-time testing is a different thing. They must have very accurate kind of code profiling and things like that. Andreas saying profiling. Patrick has a question actually, which we should probably address because, as I said, he comes up quite a lot. Where did it go?
While you're looking that one up, I want to address Remy's question real quick, or comment. He says he used Intel vTune, which is a powerful profiler. He was surprised that you could use it with Delphi. So that's a good point, is that a lot of other general profiler tools or general tools will work with Delphi applications if you turn on full debug information, because it uses a standard debug file format, and it can then, these other profilers can use that to instrument the program at runtime. So yes, that's a really good point.
Right.
Yeah, we should probably mention, we're on the profiler slide at the moment. I haven't done any profiling in years, but I've played around with a trial of AQ time, and I think I've used the sampling profile in the past on that list. But I don't know if anyone else can comment on any profilers they've used.
Well, I mean, I've used ProDelphi and AQ time, and I think I might have tried Nexus, but I don't remember it, so I can't really comment on it. But ProDelphi is it's much more of a homespun product, but very effective. AQ time is much more polished and more expensive.
Yes, but ProDelphi's free, isn't it?
No, it's not free. It's
not free? Okay.
I could be wrong. I think there might be a free version, but I remember paying for it, so maybe he's made it free, and I've spent my money and lost it. But but I tell you what, good luck to him because it was worth every penny. AQ Time is extremely effective, and it's very popular. Plenty of people like that as a product, but I personally like Pro Delphi just because it did what I needed to do and understood what it did, which is more important. AQ Time is it comes up frequently when people are talking about profiling and optimization and things like that. It's one of those things that people say, oh, you should use AQ Time, but yeah, they're good. Patrick's question, actually, Jim answered it, but it was about using attributes and RTTI, whether it's good or bad practice, and for when response times are vital. I actually use attributes. Not everybody understands what attributes are, but I do use attributes when I'm doing things with TMS Web Core and Xdata kind of stuff, because they use that to decorate classes and things so that there's a more easy translation between, say, a JSON class and a Delphi class, which is actually a very good use of attributes, but people use them for other reasons to decorate classes.
If you so big overheads involved whenever you use RTTI, but so you shouldn't just use it.
No, don't use it just for the heck of it. Yeah, use it sparingly.
Yeah, but sometimes you need to access a private property or something like that in a class, and it's the only way really to do it. So it's kind of my use case typically.
Xdata uses it for mapping, so it maps the classes that are used for the data against the JSON calls and REST calls and things like that. I don't know. There's different ways of doing these things. Yeah, it's one of those, and actually they're not the only ones. I've seen a few other packages do that as well. RTTI is one of those things where it can be very, very useful, or it can get very tricky very quickly. Some people, you see them end up going down a rabbit hole where they've used RTTI so that they can write this kind of generic code that deals with almost everything at the kitchen sink. Go, that's okay, I can resolve it with the RTTI. And that's when it starts to get really messy, because their solution started out as being very clever and succinct, but the further down the line they go, they actually would have been better off not doing it that way. And it's just, I don't know. I guess the more code you write, the more you will occasionally come across something and think, maybe I should rewrite this and not use it that way.
Yeah. Should we go back in slide-wise? Should we go back to the memory leak detection? I think that's back to
that one. Yeah.
Yeah. I mean,
we didn't really talk about this, did we? Yeah.
No. So I think we should try and get before we finish up. We should probably get through all the slides.
Sure.
Good point.
But I use FastMM for my memory leak detection, and there's so it's built into Delphi, but FastMM4 is I think it's on GitHub, and it has more powerful tools. So the report memory leaks on shutdown by default will tell you that you've leaked memory and tell you what you've leaked. But if you get the full version of FastMM, which is free anyway, FastMM 5 is new out, and it has a commercial license, but FastMM 4 is just open source and very permissive license. So, but it'll tell you line numbers, where things have leaked. It can still be a bit of a challenge to work out, because if you leak a string list, you might have a number of strings and various other bits and pieces that also get leaked at the same time. So that's what I use, and I have when I start my application from the IDE, I always have report memory leaks on shutdown set to true. So when I'm debugging, when I quit, it'll tell me if I've made any mistakes in any new code.
I think it's one of those things where it should be on by default for everybody, because I think
probably should be an option in the IDE to turn it on.
Yeah, and I have it on all the time, and the reason is because I forget to do things. I'm a human being, and I want the system to start thinking for me, to overcome some of my stupidity. So.
Yeah, I've had a brief play around with Deleaker, but I've not actually used it
I'm not using it, unfortunately.
Most of my code doesn't leak. I haven't got any major memory leaks that I need to resolve. So it's and some of the profilers will also detect memory leaks for you in your application.
Yeah. So Andreas Dawn says, is there a profiler on Windows that shows the results in a good tree map? On Linux, there is valgrind and cache grind. It works with Lazarus. Never heard of Lazarus, don't know what that is. Just kidding. And it's awesome there. The short answer is I don't know. Pro Delphi does a little tree and all sorts of things, but it's not how I use it. Either the other two of you know? I'm guessing not, based on.
I know. Wagner has got a link there to one of his blog posts on memory leaks, and he's got a huge. I had a brief look at it. If leak detection is an issue for you, then you need to read that blog post that's listed there.
Yeah, it's surprising how many people's programs do leak and they don't realize. And
yes.
The one that I don't know how many people write Windows services, but I have quite a few because of what we do. And that's when you find whether you can write code that doesn't leak. Because Windows service, like we have some automatic reporting and stuff like that, runs in the background. If that leaked, it would bring down an entire server. And once that happens, you'll soon find a customer may not necessarily want to hear your excuses to, well, it was a memory leak, it wasn't my fault.
And it might be running continuously for 3 months or something, they're working quite hard.
Yeah, well, and also some third-party libraries have memory leaks. It just happens, they're human as well, and they make mistakes. But turn on your memory leak, and then you'll see there was one. I don't want to call out the library. I'm trying to remember who it was, but every time the program closed, it would come back and say there were a bunch of handles that had been left hanging, and this is in the third-party library, and. It wasn't a massive problem, but again, if it's a Windows service or something that's designed to be around for a long time rather than run every so often, it's a problem.
I mean, most memory leaks aren't a big deal, but if you have something in a tight loop that's leaking memory, it'll bring your application to a grinding halt pretty quickly.
Some of our services run for years, literally. The Linux ones definitely. It's not uncommon for a Linux box to have an uptime of years, literally.
Yeah, the way that it can patch itself without restarting is amazing. So there's a comment here. Michael's saying that his flash memory reports so many memory leaks in his flagship product doesn't know where to start. And so this is a good time. Like you're saying that some memory leaks aren't a big deal. What you have to be concerned about is that memory leaks that increase or handle leaks that increase over time. So if every time your program runs and you shut it down, it leaks the same thing every time, that actually is not a big deal, because when it shuts down, generally speaking, all the memory is freed, all the handles are freed during the shutdown process. There are some exceptions to that, but generally speaking, it's not a big deal. But where you have a big deal is when something is continuing to leak over time. And I did some time as a .NET C# developer, and C# has garbage collection, and so it doesn't leak memory. And I'm doing air quotes, but you can't see because webcams isn't working. You can still leak memory in .NET, but it's not really leaking memory, because if you have a object that still has a reference to it someplace, but you're not using it anymore, that's a memory leak.
Yeah.
It's still in memory, and you're not using it, and your program starts using more and more memory over time. So it's kind of a weird thing. It's what I'm concerned about is when something is using more memory over time. That's the ones that are concerning. And like Ian was saying, right, if it's a service, then that can be a very small amount of additional memory because it's running for such a long period of time. It's a big deal. But
it's like your programs. You should fix all your hints and warnings. You should fix all your memory leaks, because you might get one that is a problem and you won't notice it because you're leaking so much other stuff.
I mean, Windows updates have really made it a lot easier because they make the machines reboot every week.
Yeah.
Or patch Tuesday once a month. But it you know, like I say, we have, I think, at least 5 services in our kind of core product, core client server product, including, you know, other services that we use like MySQL and PHP and things like that. But the MySQL is usually fairly robust, and the biggest problem with that is, of course, security patches. But with the Windows services, ironically, yes, it is not as much of a problem because Windows itself is unstable enough. It does need to be patched. That reboots and that clears a memory leak. But it depends, as you said, on the size of the memory leak. If you're doing something like creating a PDF and you're doing something bizarre like storing that in a graphic, you know, image or something like that, it's not long before you can eat up memory. And if it's only a few K each time, but that runs 100 times a day, it's 4 or 5 days before you're using gigabytes of RAM. And we all know, you know, people's systems suddenly start to slow down over a period of time. And I wonder how often it is actually a memory leak in something. Because you go and look at your, you know, you look at Task Manager and you try and see, why is my machine so slow? And you're looking at the, you know, the CPU not saying 100%, but seeming to be very slow. And who knows, you know, amount of memory used 98%. And something's bad is happening. You just don't want to be the one whose fault it is, really. That's how it works for me. You know, customers are not very forgiving when they're corporates. What's this? If it does not fail, we lost Jim's video. That was a while ago. Yeah, we're back again. So.
Yeah, okay. Alf pointed out Eureka Log is a good result. Mat Accept is another one. They can capture that as well. What was that?
Hotlog, also a very good logging system as well.
Oh, I've not used that one.
Yeah, it's open source, I think, as well. It's actually pretty good. I've used Hotlog and Eureka Log, and I've used Mat Accept quite heavily. Mat Accept is probably the most useful that I use because it would send you call stacks and screenshots and things like that. You have to warn the user because obviously if you're working in the payroll industry, the last thing you want to do is take someone's screenshot and get it sent back to you in a normal email and get intercepted. So you need to encrypt these things, but Mat Accept allowed you to do some of those things in advance. But very, very good system, Mat Accept. I've got a lot of respect for is it Kim Madsen? I forget his name, but very good. That's right. Yeah, Kimbo Madsen, very, very good programmer. Where are we at? Let's make sure we've answered some more questions. Local subprograms use no variables yet. Turbo.
So the comments are about inline local variables versus global variables. Really, the thing about you having variables, doing variables the smallest scope you need. I mean, there's some of that comes into, you know, whether they're placed on the stack or the heap and pushing things onto the stack and pulling them off to the stack and stuff like that. But also the number of side effects that can be introduced, right? So if your variable exists in the larger the scope your variable exists in, the more likely it is to be modified outside, or more possibilities it is for it to be modified outside of the scope you're aware of. And so then you have side effects. And so that's a making your code more loosely coupled, which has a number of benefits. But it can also be a performance impact as well, because, well, let's see.
Set up and tear down code.
Yeah, set up and tear down, stuff like that. So it depends on the type of variable too.
So much global state for performance reasons. It was kind of a nightmare to work with, but yeah, it was a highly performant system. It didn't use classes because that was all too slow. It uses pointers to records. So yeah, it was. But it originally designed pre-Pascal. It was written in a Pascal-like language. It might have been Ada, and then Pascal, and then Delphi. So
Kirk M. Holgren, sorry. He says spaghetti structured, OOAD, functional are the styles I've seen, and I started with Fortran. Well, I've seen even more than those. And he's saying, would you have predicted in the 90s the kind of programming you're doing now? No, absolutely not. I mean, around about 96, I definitely could predict the kind of programming I do now, because that's when Delphi came out. The minute I saw Delphi, I knew that was the way I was going to go. And the reason was, and this is a fact, that at the time I was a fairly widely experienced Visual Basic programmer. It was Visual Basic 3 and Visual Basic 4 was coming out. And I know it sounds weird, but I'd done C stuff. I was a system developer for Unix. Used to be able to build kernels from scratch and patch them on the fly and things like that. So I was a COBOL programmer, and I saw Delphi, and it immediately made sense to me. This was a programming paradigm that made a lot of sense with the classes and the objects. And there was OWL around before, in Pascal and things like that. But this was the first time where it was a language that really clicked. So could I have predicted in the 90s? No. But once Delphi came along, that was the way I hoped it would go. Since then, obviously, things like Python have become more popular. Python's as old as Delphi, but Python became more popular. But to me, Python was always like a scripting language, a bit like DOS scripting, batch files, or later on, PowerShell scripts or something. It's become more than that. It's become more than PHP, for example. But it always, at that era, it seemed like it was a way of scripting things. So, object orientation allows us to do much more of this profiling and stuff like that. And the memory leaks, yes, they do come about because of classes and objects, but also because of doing daft things with memory, where you allocate some memory and then don't deallocate it. And that happened in C long before objects turned up. So,
and in Pascal, I mean, you could allocate a record on the heap, and you need to be able to free that manually. I forget what the commands are. It's been so long since I've done any of that in Pascal.
Free mem, I can't remember either. It was just
but yeah.
Craig says he really enjoys listening to webinars, but the time is so awkward for you. Can the recordings be made available sooner? Craig, Jim is partially responsible for that, not me. But it is, we do our best. We do stream to YouTube at the same time, and we're trying to get them up more quickly. But
so is the YouTube stream available immediately?
Yes, the YouTube stream is available immediately. The past few weeks, the YouTube stream has been available immediately. So,
okay. Yeah. So you can get them. We do our best, and we are trying to do more about it, and we're going to try and do more on the blog to, give you a place to go to look at as well. So, sorry, everybody has lots of other work to do, not just TCoffeeAndCode every week.
Shall we get to the last couple of slides before the end of the hour, and then people can carry on listening to us ramble on things, or
I don't ramble. How dare you? Oh, wait, no, I didn't.
So it's important information we're imparting. So mentioning SQL performance, Delphi does databases fantastically well. So there's a lot of databasing apps written in Delphi. So your performance of your application is tied to the SQL database as well. So definitely you want to look at how you can improve your queries and what have you to make your application quicker.
Yeah, it's I think the database I use the most is MySQL. It has some profiling tools, but not as many as SQL Server. SQL Server kind of rules the roost, really, and when it comes to that.
Yeah, the SQL profiler and that is amazing, and you can have that running and just looking at the SQL that your your application is generating as it's running, with all the profiling information attached to it, is really handy for, I think it's, you just start your application and look at all the SQL that's being executed and see what you can optimize. And there is built-in profiling in FireDAC as well, which you should take advantage of if you're using FireDAC.
It depends on the type of development you're doing as well, because the place that I worked at that used SQL Server the most actually had DBMS guys, and it was their job to provide views and store procedures and all those kind of things in SQL Server, and then it was our job to just manipulate those stored procedures and things like that, and they would optimize what we were getting. And that may be the case for a lot of people. But if you are more down to the metal where you're doing all of that yourself, then obviously it's much more important, tool. My dog is coughing.
Yeah.
Hey, you okay? Don't throw up. Oh, that would be bad. Yeah,
Yeah,
glad the
I've
webcam's not on.
Yeah, played around with putting. You can use that if you've got Azure. You can put your SQL Server database in the cloud, and you restrict by IP and stuff like that. So you can run. So basically means your latency is really quite large. So if you're looking at situations like that, yeah, you really want to minimize the amount of traffic that's occurring.
And also use somebody else's credit card for the Azure.
Free sign up.
The minute you sign up to Azure or Amazon, they suddenly drain your bank account the minute you go live with something.
Yeah, it's quite scary, really, isn't it? Because there's it might have up to 200,000 transactions free, and then you're paying
well, there's a couple of webinars coming up, about exactly those things. I think it's probably worth talking about those when they come, because the great thing about Amazon and Azure are the number of services they offer. The bad thing about Amazon and Azure is how you pay for those services and how you work out how much you're going to pay. I don't know about you, but whenever I go to do something at Amazon and someone says, oh, we want to do notifications, and there's a simple notification system on Amazon and it's dead easy, there's an API for it, and there's a Delphi translation of that API, and then you try and work out exactly how much it's going to cost you to send those notifications. It's almost impossible to work out, are you going to be bankrupt in the first 2 days, or is it going to run forever on 75 cents? And it's quite a dark art. So yeah. And whilst we're on the subject, books, a couple of really good books. Primoz, he's a very, very good writer, very well respected by every MVP. Has got a lot of respect for Primoz. He's been around.
I definitely recommend his Delphi High Performance book.
Absolutely brilliant book.
If you're wanting to do, it covers far more detail what we've talked about in this session.
Yeah. And also Dahlia, who was on last week, her memory management book, and she's got another book as well, along similar lines, about some sort of fairly hairy sort of technical stuff. But
asynchronous programming. I suppose I probably could have added some multi-threaded stuff in here as well.
Really both her books kind of lead into that subject, don't they? She's a pretty smart person. I've got a lot of respect for Dahlia. A little bit crazy as well. I like that about her. She's got great sense of humour. It's a good thing. Yeah, the industry we're working can be very dour and depressing unless you take it with a pinch of salt and don't take yourself too seriously. I think that's one of the best advice I can give people. So what else? I think we've kind of covered most.
Conrad says that MatAccept is by somebody else, so we may have said the name wrong. Let me look it up.
Yes, he said, I forget who he said it was. Oh, Matthias Ruin. Sorry about that, Matthias. We've been cruelly horrible about it. All we can say is MatAccept is brilliant, and you definitely should pay for a system, because they've got a kind of a donation-ware, I think, pay model. I could be wrong. It may be completely free, but I'm not sure. But definitely MatAccept. A lot of experienced Delphi people would say the same thing, that MatAccept, great system, got some very, very good features. Yes. Oh, Matthias Ruin says Holger. Rowan. Yeah, he's not giving me a pronunciation guide. He's spelling it, but it looks the same as the way I'm saying it, so I'm saying something. Yeah, I'm not going to get into a fight over German pronunciation. No, that's not my speciality. I think we've established that here. Yeah, great stuff. Okay, I think we've answered most people's questions, don't you, Jim? There are a lot more. Oh, he says correct now. I've got it right. Rowan. Okay, good. Matthias Rowan.
And there was a comment about sometimes you have a bug that when you start debugging it, the bug goes away. Yeah, those are called Heisenberg bugs, where the act of measuring the bug changes the bug performance.
Yes, is it a bug or isn't it? It's not a bug when you go and look for it, but the minute the customer uses your program, it comes back. Yes, it's and I'm always uncertain about how to fix them. Yes.
Yeah, I like a threading bug or a memory, overwrite or something like that.
I'm very tempted to do a webinar, or not so much webinar, but a presentation sometime about people reporting bugs and how, as Delphi developers, we should probably include a mechanism on our programs to do that, because so many people are so bad at reporting bugs. You know, they'll say things like it doesn't work, and they'll send me like a report, and it's got 16 pages in it of numbers, and I'm supposed to guess which one of those numbers is incorrect and why. They'll say, oh, the totals don't add up.
Guess at what the bug is and give you some completely
and what
inaccurate
report
information
did
that
you use there?
irrelevant.
You know, what version were you using? And all, yeah. So you know, it would be an interesting little session I might have to do at some point, I think, as well. Okay, well, I'm kind of at an end, Jim.
All right, sounds good. I'm going to go through the last couple of these questions here as well, but yeah, we can go ahead and wrap it up. Thanks everybody for joining us.
One more thing to mention. I pasted a link into the chat, which is a movie that I did for the Australian ADUG Symposium, so the Australian Delphi User Group in 2016, yes, on fractals. And I sort of did a little live coding on this, and it's a lot of parallel programming, so code optimization stuff in there. And so it looks at taking the basic code for generating a Mandelbrot set, and then making that parallel using inlining, going to 64-bit, which for some applications, if you're using a lot of 64-bit data types or large data types, then 64-bit can effectively double the performance of your application.
Wow. Yeah.
It can also make your application slower if you're not. So.
Yeah. This is one of those things.
So that's my movie 116. If you go to learndelphi.tv or click on the link in the chat video.
I will be watching that.
I was quite proud of that one. I did rehearse that a lot and did most of the coding live. 95% of the code I did live, and I pasted in a little bit related to the actual rendering on the FireMonkey canvas for a.
What is the difference between 116 and 116B?
Okay, so I did. I did the talk in Sydney and Melbourne. So I've got both versions available, I think, if that's what you're referring to.
Okay. I just was looking in the thing. You have two links. So there's three links. One is just the Mandelbrot set, and then you have this was a talk, and then you say watch this presentation on YouTube, and those are the Melbourne version. Okay, Melbourne version. Okay. Yep, I see that.
Yeah, so that was a very fun talk to do. And I did ramble. There's a bit of rambling at the beginning on how fast computers have gotten since sort of Cray supercomputers were a thing, and now your phone is faster than a Cray supercomputer. So
I know, this boggles the mind.
I went to the University of Copenhagen, and they had a crane there, and they said, "Would you like to go and see the crane?" I said, "God, of course I would." It was fantastic. It was turned off, and so I was able to go and stand inside and put my head inside the Cray supercomputer. It's a very bizarre experience, but not one you get very often, I think.
Yeah, that's really not worth anything anymore because apart from nostalgia value.
They were using it as a chair.
I love the Computer History Museum in Mountain View. They have crays and stuff like that. But if you can get a chance to get one of the tours, and I would say go multiple times because each tour guide gives a different tour. But they remember there was this one system they have that was this system for calculating. Well, actually, this was a really big thing over the years, is the calculation of parabolic curves. It used to be that you would have these manuals, paper books printed out that you'd look up and have to find the, you do your measurement, your ranged measurements and stuff like that for like shooting missiles or mortars or whatever, and you have to look it up in this book.
Parabolic curves are very important for blowing things up.
Yes, but then the crazy thing is, Angry Birds is all about parabolic curves.
Yeah,
and it's like
that really is parabolic curves of things being sent into the air and landing back down with a bang. Yes.
And really
it
quite
just
impressive physics simulation as well, with things falling over and what have you. Yeah.
Yeah, that's funny. Angry Birds. There was a seminal moment with the Angry Birds being released. That was someone came up with a really brilliant idea, and you think that would never succeed. No, it did. It did really well. They made a lot of money out of that.
Yeah.
Crazy.
Yep. All right, great. Well, thank you everybody for joining us, for being part of TCoffeeAndCode. I do have a lot of stuff planned and changing and involving TCoffeeAndCode, so the fact that the list of upcoming sessions is shrinking, don't worry. I definitely want to keep this going, but there may be some changes in the way it works. So we'll see you all in future sessions.
Have fun, everybody.
And
Bye-bye.
Yeah.
desktop first. Take care, everybody.